We'll look at another example of the simplex method, still in two variables. But we're going to start with an actual word problem talk through to remind ourselves how to set up the problem before we actually work through the problem. All right, in this case, we have a company that manufactures two products, A and B, on two machines, 1 and 2. And it's been determined that the company will realize a profit of $3 per unit on product A and a profit of $4 per unit on product B. Now, this is where we find the objective function. Right, we want to maximize the profit, and in this first sentence is giving us how the profit is determined. We have $3 per unit on product A, $4 per unit on product B. That's where the profit function comes from. If we let X be the number of units of product A and Y be the number of units of product B, then our profit function is 3 times X plus 4 times Y. Okay, now for the constraints. Our first constraint is going to be the time available on machine 1, and the second inequality will be the time available on machine 2. Now, it says that to manufacture 1 unit of product A, this requires 6 minutes on machine 1, 5 minutes on machine 2. To manufacture 1 unit of product B, it requires 9 minutes on machine 1 and 4 minutes on machine 2. Okay, so this first one, right, this is for machine 1, right? X represents product A, Y represents product B. Second inequality is machine 2. Okay, so we know that machine 1, we need 6 minutes on machine 1. That's the 6X for product A. We know we need 9 minutes on machine 1 for product B. That's the 9Y. And we only have 5 hours available. Now we're talking about minutes, so we need to convert hours to minutes. So there's 60 minutes in an hour. 5 times 60 is 300. That's where this 300 comes from. And then for machine 2, we have 5 minutes required for product A. That's the 5X. We have 4 minutes for product B on machine 2. That's the 4Y. And that must be less than or equal to the 3 hours of machine time available on machine 2. That's the 180 minutes. Okay, once we have that set up, then we can proceed with our simplex method. Okay, so to go through those 8 steps again, let's refresh ourselves. All right, step 1, what we want to do is we want to convert the inequalities to equalities by introducing slack variables. 6X plus 9Y plus U equals 300. That U is forcing equality. 5X plus 4Y plus V equals 180. Then step 2, we're going to rewrite the profit function. We're going to set it equal to 0. So by subtracting 3X and 4Y from both sides, that gives us negative 3X minus 4Y plus P equals 0. Okay, we can now write this as a matrix. 6, 9, 1, 0, 0, 300. 5, 4, 0, 1, 0, 180. Negative 3, negative 4, 0, 0, 1, 0. And now we need to know what our pivot is, right? That's the most negative column and the smallest ratio. Okay, so our most negative entry in the last row is negative 4. All right, so we're using the second column. And then we divide the constant on the right-hand side by the number in the second column. 300 divided by 9 is, I'll reduce that to 100/3, which is 33 1/3. And then 180 divided by 4, which is 45. So we're taking the smaller of the two ratios. So we're going to use this 9 as our pivot. We want to make that 9 become a 1, then everything else in the column becomes zeros. So we will do that by multiplying row 1 by 1/9. 6 divided by 9 is 2/3. 9 divided by 9 is 1. 1/9, 0, 0. And 300 divided by 9, I'm leaving that as 100 over 3. Everything else stays the same. All right, now I want everything else in column 2 to become 0. So I want row 2 to become 0. I can do that by subtracting 4 times row 1 from it. And row 3 becomes 0 by adding 4 times row 1. All right, getting into some heavy fractions here. So make sure you have a calculator that can handle fractions for you if you struggle with fractions. All right, row 2 minus 4 times row 1. That is 5, 4, 0, 1, 0, 180. And then 4 times row 1 is negative 8/3. Negative 4, negative 4/9, 0, 0, negative 400/3. All right, 5 minus 8/3 is 7/3. 4 minus 4 is 0. Negative 4/9, 1, 0. And 1/43. That's 180 minus 400/3 gives us 1/43. Okay, and then row 3 plus 4 times row 1. Be 8/3, 4, 4/9, 0, 0, 400/3. That's the 4 times row 1. All right, so negative 3 plus 8/3 is negative 1/3, 0, 4/9, 0, 1, and 400/3. Okay, so now second column is done. Now we look to see if we still have negatives in that last row. We do in the first column. Okay, so first column is going to be our new pivot column. And when you check our ratios to see which one will give us the smallest, okay, but I'm going to make an argument here that it's got to be 7/3 because we are still doing this Gauss-Jordan elimination, modified procedure to where if we already have a 1 here and we only have 2 variables, then this has got to be the 1, all right? So you can't have 2 1s next to each other, right? They're going to be alternating, right? So that's got to be the 1. You can verify that by checking through the ratio. That 1/43 divided by 7/3 is smaller than 100/3 divided by 2/3. Okay, so then in that case, we need to get that 7/3 to become a 1 by dividing by 7/3, which is the same as multiplying by 3/7. Okay, 3/7 times row 2. 3/7 times 7/3 is 1, times 0 is 0, times -4/9 times -4/9 is 4 over 21. Times 1 is 3/7, and then 0. And then 3/7 times 1/43 is 20. Right, the 3's cancel, and 140 divided by 7 is 20. Okay, so now that we have a 1, we want everything else in the first column to be zeros. So we can make that 2/3 become a 0 by subtracting 2/3 times row 2 from row 1. And adding 1/3 times row 2 to row 3. All right, we'll come down to our scratch work and have R1 minus 2/3 row 2. All right, -2/3 times row 2 is -2/3, 0. It's 4/21 times 2/3 is -8 over 63. -2/3 times 3/7. The 3's would cancel. That leaves us with a -2/7 there. 0 and 20/3. Let me back up here. Not 20/3, right? I should be multiplying what? -2/3 times 20. -2/3 times 20 is a negative 40 over 3. That should look better. So we have 0, 1, -1/63 minus 2/7, 0, and 60 over 3, which is 20. So 0, 1, -1/63, -2/7, 0, and 20. And then finally here, R3 plus row 1/3 times row 2. Okay, 1/3 times row 2. That's 1/3, 0, 4 over 63, 1/7, 0, and 20/3. Okay, so that's 0, 0, 32 over 63, 1/7, 1, and 420 over 3, which is 140. So that last row, we got all these fractions here in these third and fourth columns. Remember, that's the slack variable column, which really doesn't have any significance to what we're working with. Right, we're focusing on this last column. Right, this tells us that when we produce 20 units of product A, 20 units of product B, that will give us a max profit of $140.